Next, we have to discussing about Unit 3 process synchronization and deadlocks. First one, what is a process synchronization? Process now, what is a process? The job will be scheduled, the job will be executed, the job will be processed to execute. These are the process synchronization. Synchronization is nothing but the process will be executed or not. That's the purpose for synchronization. There are the two types of processor. First one, cooperating process and independent process. Cooperating process na, it will be to be affected by the execution of another process. Any affected by the execution period na, the cooperating process will uh, help to relieving the job or otherwise help to executing the another process. Next, the process will be shared the data with the logical address space. Next, what is the independent process now? That we do not share any data. Next, producer consumer problems. What are the producer consumer problems now? The process between any problem between two process, like a producer consumer problem. It will be called as producer means the process will be executing period like called as producer. Consumer na the expecting outcome from the process na it will be called as consumer. These are the producer consumer problems. Producer problems produce the fixed size buffer. Next, consumer problems process will be expected the outcome of their process. Next, there are two type of buffers. Buffer no nothing but it will be storage. Unbounded buffer, bounded buffer. Unbounded buffer no there is no practical limit in the size of buffer. Next, bounded buffer no it will be fixed buffer size. It will be considered fixed buffer size. Next most important condition, race condition. Why the race condition is most important now? The situations will be this several process will be access and manipulate some data concurrently, or otherwise the outcome of execution will depends upon particularly. What I am telling now? The race condition now, the many jobs will be assigned. If data are continuously sharing now, if any exhibition timeல ஏதோ ஒரு கண்டிப்பா ஏதோ ஒரு ப்ராப்ளம் நடக்கும். It will be stopped by the race condition. Next, critical section. Critical section it will be called as code segment. Next, no other process will be allowed in that critical section. Next, type of section entry section, exit section, remainder section. Entry section it will be section of code will be in implementing the request permission to enter the critical section. Next, exit section, the code to be leave in a critical conditions. Next, remainder section the code will be the process by critical section. Next, bounded waiting, mutual exclusion process. Mutual exclusion, no other process will be executing in the mutual after the critical section. Next, progress, some progress will be enter into the critical section. Next, bounded waiting, a number of times will be the job allocated, but no more process will be granted. It will be called as bounded waiting. Next, mutex locks, it will be called as mutual exclusion. It will be solved the critical section problem. After that, the job will be executed in the mutex locks. Next, illustration. There are more locks are available. Acquire lock, release lock. Next, if it is some critical section, not will be allowed the jobs. But acquire lock, what they do now? The acquire lock section, they will give a job to the critical section. They have to complete and next it will be release. These are the functions used in the critical section. Next, sync semaphores. Semaphores it will be a tool and it does not require a busy waiting. Next it will be has a integer value for a semaphore. Next, what is the usage of semaphore now? If had a two or many process can be cooperated by the simple signals, it will be called as semaphores. I mean usage of semaphores. Next, a deadlock, it will be situations that occurs the two process are waiting now. It will be complete the before proceedings. If many jobs are allocated now, it will be called as queue. It will be first in first out. The deadlock will be proceed as situation like first in first out. Next, what are the types of deadlock now? Process deadlock and system deadlock. What is the process deadlock? The deadlocked is waiting an event which will be in happened. Next, system deadlock, it will one or more process will be deadlocked. Next, system model. First one, reusable and consumable. Next, it will be what is the characteristics of deadlock, mutual exclusion, hold and wait, no prevention. These are the characteristics of deadlock. Next, circular wait. Many resources are available in a circular wait. Many resources can be does not do a job at the same time. It will be has a circular wait process. Circular wait process na until completing first job cannot be allowed to the next upcoming jobs. Only completed the jobs na next we have allowed the next jobs. These are the performance by the circular wait. Next, resource allocation graph. Why are we using resource allocation graph na? If one process or one job will be completed, next will be allocated for the another job. Now the resource allocation graph will be mentioned. Okay, upcoming jobs or upcoming jobs are 100. We have to allow the one by one. We have to allow the resource allocation graph. Then only we have the upcoming jobs will be scheduled. Next, resource allocation graph na process, resource types, request stage, climates. There are many resource allocation graphs are available. These are the graphs in deadlock. These are the graphs under the no deadlock. When it occurs a deadlock, na how many deadlocks are happening, how many process and resources are allowed in a deadlock. Here, there is if any no deadlocks are available, na no deadlocks are allocated or no deadlocks are happened. Na what are the graphs out here? Next, what are the solution for deadlock? Why you are using deadlock? Why are how we come to overcome from deadlock? Na first one, deadlock prevention, avoidance, reduction, recovery. Prevention, mutual exclusion and hold and wait. Mutual exclusion will be sharing some resources. Hold and wait. If sharing resources, na we have to hold and then we have to proceed. Next, no prevention and circular wait happen. Next, what are the avoidance? Resource allocation state will be the number of available and allocated process will be defined. Next, safe state. Thank you.